So today we are looking at theoretical probability, and we're going straight into the examples. Example number 1. Consider the 3 spinners shown below. So we have one spinner that is half red, half blue. That would be an even chance of each. The next one is red, green and blue. We had one like that last time where the red was meant to be slightly smaller, and then we have the one down the end where we have 2 pieces of red, so it would be even chance of red, but then blue and green would be less than likely. So what is the probability of spinning blue for each one of those spinners? When we do probabilities, we like to write them as fractions most of the time, okay? The bottom number of the fraction is the total number of pieces, okay? So the first spinner has 2 pieces, so it'll be a 2 on the bottom. And then the top number is how many of them are favourable, and in this case we want how many blue ones. So there is 1 piece out of 2 which is blue, so that's how we get the half, or the even chance. In the second spinner, there are 3 pieces, and 1 out of the 3 pieces is blue. And in the fourth spinner, there are 4 even pieces, and 1 out of the 4 is blue. So that is how we find those probabilities. Part B. What is the probability of red for each of the spinners? So we're going to go through and do it again now for red. The first one, there's still 2 pieces, and 1 out of the 2 pieces is red. I'm just doing them underneath each other. So this is first spinner, second spinner, third spinner. They'll all be underneath each other. In the second spinner, 1 out of the 3 pieces is red. And the final spinner, we have 4 pieces, and 2 out of the 4 are red. Now, in a test, we would actually give you that as correct. You don't have to simplify fractions, but 2 out of 4 does simplify down to a half if you would like the simplified answer. Okay, question 2. A spinner with the numbers 1 to 7 is spun. The event being considered is spinning an odd number. Now, the first thing I want to do is list the sample space. Now, that is everything, not just the favourable outcomes that I was talking about, being odd numbers. That comes in down here. But when it says sample space, it means everything that you could get when you have a spinner with the numbers 1 to 7 on it. And the correct way to write it is S for sample space equals, then you have to try to draw these funny brackets. I'll do it again over here. You do like a half loop, little point in the middle, and then another half loop. But when you do them faster, it kind of ends up a bit of a squiggle for me. Anything that looks roughly like that is fine. Inside those brackets, you list off all of the numbers. 1, 2, 3, 4, 5, 6, 7, and then try to close your squiggly brackets. Okay, that is how you write a sample space. Part B, we want to list the favourable outcomes, and the favourable outcomes was getting an odd number. So we're going to put that in our brackets again. It's not a sample space, so I'm not going to say S equals because it's not a complete sample. It's what we call a subset. That's a technical word that we don't use much of this year, but that's its official name. And the odd numbers are 1, 3, 5, and 7. It's a subset because it's a smaller group of the original amount. So it's just the odd numbers coming out of that one. Question 3. A spinner with numbers 1 to 5 is spun. The event being considered this time is an even number. But first of all, before we do the even numbers, we want to list the whole sample space. So whole sample space is S equals big squiggly bracket, and we have numbers 1 to 5. So 1, 2, 3, 4, 5. That's the whole sample space. In part B, on the next page, says list the favourable outcomes, which will be the even numbers. There's only 2 and 4 that are even. So we open our squiggly brackets and we have a 2, 4, close squiggly brackets. Question 3. A fair six-sided dice is rolled. Find the probability of rolling a 3, giving your answer as a fraction. You don't have to write this down, but this would be the correct notation for writing probability of getting a 3. So that's what that means. If you ever see something written like that, the P stands for probability, and whatever's in the brackets is what you want to find the probability of. You won't get marks for that. You won't get marked down if you don't write that. But that's what it means. What you need is the answer that I'm about to put down, which is the fraction. If there are 6 numbers on a dice, there's going to be a 6 on the bottom. How many favourable outcomes are there? How many 6s are on a dice? Just 1. So there is a 1 in 6 chance of getting a 3, sorry, not a 6. A 3 on your dice. Part B. Find the probability of rolling an even number, this time giving your answer as a decimal. Okay, so I'm going to start the same way. Probability of getting something that is even. Now your even numbers are 2, 4, 6. So there is 3 of them out of the 6. Now some of you probably know what that is as a decimal already. 3 out of 6 is a half, which means that that's going to be 0.5. For harder ones, you just need to put them into your calculator as a fraction. So here's a calculator here. So I could type in 3 over 6, and it would even simplify my fraction down if I wanted it to do that. On your calculators, to make them go to a decimal, you can go through your format button, or you can just press Shift Execute, and it will change it into a decimal. Okay. Part C. Find the probability of rolling a number greater than 4. Now, the greater than symbol is that, or you could write the word greater than. If you forget, that's okay. So greater than 4. If I say greater than 4, does that include the 4? No. So the numbers that are favourable are the 5 and the 6. There is 2 of them out of 6 that are favourable. This time I want my answer as a percentage. Can anyone remember how to turn a fraction into a percentage? Seb? Yeah, kind of. If I could change it to be out of 100, that would kind of work. Any other suggestion that might be easier than that? Do you want to try? Yeah, that's kind of along the same lines, but I'm looking for something else. Yeah, different, Bella. You can do that. So if it was a nice denominator, like if that was out of 10, you could times everything by 10 to make it out of 100, and whatever's on the top is going to be your percentage. But 6 is not nice. You're not going to be able to multiply something nicely from there to get a denominator of 100. So when you do a test, for example, and you get a mark like that on your test paper, we write it as a fraction. To turn a fraction into a percentage, all you have to do is multiply it by 100. Okay, so you get your calculator out, and this won't be an exact number, which is why we couldn't do it with the other method very easily. So we go 2 over 6, use the across button, and go times by 100 equals. You'll have to press Shift Execute to get your decimal. So 33.333333. Or we could write that as 33.3 with a repeater dot %. Oh, but that's not right, is it? What did it say in the question? Give your answer correct to 1 decimal place. So if I only want 1 decimal place, it means I want to round it. So I'm just going to go 0.3, and the rest of the 3s would round off. I don't need the repeater dot if I'm rounding it. If it was exact, if I was doing it exact, I would put the repeater dots on there, but that said round it to 1 decimal place. It rounded the one that we had 66666, and it rounds up to 7, but 3s round down. So no, you're not going to round that one. Okay, so we're doing pages 24 to 26.